this is one of my homebrew projects. It's a single conversion Superhet for 7 megs. The IF is about 4.33 megahertz and the VFO was running at 2.7 to 2.8 megs approximately. So if you add the two of those together, you get the 7 megs band. 4.3 and 2.7 to 2.8 gives a coverage of 7 megs to 7.1 in two ranges. This is a range switch here. I can divide the band into 7 to 7.05 and 7.05 to 7.1 with a little bit of overlap and a little bit extra at each end, so it goes down to about 6.99 something, and I'm not sure what it is at the high end. The controls there are the on-off switch here with an LED to show power is on. As I said, this switches 2 halves of the 7.1 meg coverage. The on-off switch, volume control, RF control. I have an audio filter here, an active audio filter, which I just have 2 positions, narrow and wide. Even in the wide position it doesn't resolve SSB because I've optimized the rig for CW. There's a headphone socket there, and this little push button switch here activates a frequency mite, which is a small little commercial circuit I bought and bought and built and incorporated it. So it gives out the frequency of the receive, but it blanks the leading digit. So for 7 megs, 7.01, it just gives 010 would be the readout. I know it's a 7 megs receiver, so I don't need to be told that 7 is the leading figure, or 6 if I'm down at the lower end of the band. On switch on, I have the option of selecting the speed which it will announce at. I think it's about 12 or 20 or 24 words a minute, I'm not sure, but I'll demonstrate the operation on the next section of this rundown. So that's it for now. I'll remove the lid of the case, which I bought I think at Castle Donington many years ago, and the circuit is sort of cobbled from different sources, but it's quite unique, and it was originally, it was part of, this rig was part of a twin. I had a transmitter as well, and at the back of the rig there I have there's a control accessory socket for controlling the transmitter, muting the receiver during transmit, etc. But that's irrelevant to this receive rundown. So that's it for now. I'll come back with more, have a look at the insides of the rig when I take the lid off. Okay, so this is a view of the rig with the case removed, the top of the case removed, and there are several printed circuit boards. The boards were hand drawn, and then I etched them, and I didn't drill through to fit the components. The components are actually surface mounted onto the pads, as you can see there. And it works quite well, because what I do is I use the blank side of the printed circuit boards, just a drop of glue there, and I can glue the boards directly onto the plastic of the case, the bottom of the case or the floor of the case. So I'll just do a quick tour of what's in the boards. At the back there I have the mains transformer and power supply, smoothing capacitor there, and I also have an option. There's sockets there for an external 12 volt supply, battery or external power supply. There's the frequency mite board that announces the frequency in CW, and you can see shorting pins there. You select the IF by shorting or opening the pins there, so that the you actually feed the board with the VFO frequency, but then you add the IF so that you get the actual receive frequency. This board here now, this large board that you can see, that's the front end and the VFO, and you can see the crystals there. There's 2 crystals in the crystal filter. Now that black wire is actually hiding one of them. There it goes, that's a better view there. The one regret I have is that I didn't put the VFO in a metal case and shielding. It's inclined to drift a little, not too much, but it would have been nice had I put it in a case. There's the mixer that mixes the receive frequency with the VFO frequency to give the IF a 4.33. So it's a Philips 612, I think it's called an SA612 mixer. And what else is there of note? As I said, that's the front end and the VFO. The board that's underneath is the audio section, and that's composed of the active filter, which works on audio frequencies. You can't actually see the ICs, but it's centered, you know, around 600 hertz or there, about 700 hertz. So it kind of narrows the audio getting through to around that frequency. And then we have the audio section here, the chip there just under the red wire. That's the LM380 amplifier chip. And what else have I not covered there? Oh yeah, this little board here that you see glued on with the regulator, that's the voltage regulator for the Vericap tuning diode, which is controlled by the front knob. This knob here is a 10-turn. It's a 10-turn wire wound, high stability, military spec 10-turn potentiometer, and I have it tailored so that it will cover what is it, 50k there. So it covers approximately 50 kilohertz of the band in 10 turns. So each turn is approximately 5 kilohertz, which is quite good. And then there's the band switch. I can switch from the bottom end of the band to the top end of the band. So I think I've covered everything there inside. We'll now move on and take a listen, see what band conditions are like, and demonstrate the filter and the sensitivity, the RF gain, etc. of the rig. So that's the next section of this little tour of the Superhet, the single conversion Superhet with an IF of 4.33 megahertz for the 7 megahertz 40 meter band. When I switch on the rig first, the frequency might queries me. It wants to know what speed do I want the Morse that will announce the frequency. Do I want 12 words, or I think 20 words a minute? So it sends out the letter S and a question mark, and if I press the button, then it will go to the higher speed. If I just ignore it, it will stay at the lower speed. And then it'll send out the letter I and a question mark. So what it's asking me there is the IF, is my VFO running above or below the IF, so it can decide whether to add or subtract. So I'll just demonstrate that now by applying power. So you'll hear S for speed and I for whether the the IF should add or subtract the VFO frequency. So I hope we can get that okay here now. So I haven't pressed the button. So it will just default there to the speed of 12. Now I'll demonstrate there if I switch it on and select the higher CW speed. So that's the higher speed there. Now I'm just going to pick a random frequency here, and I'll query it, what frequency am I on here. Maybe I should go back to the lower speed there for demonstration purposes first. So we'll power it up and we leave it at the 12 words a minute. So we're ready to run now. So I'll query what frequency I'm on. So it's at 032. Play it again. So that's 7.032 megahertz. Now if I switch to the higher end of the band, we'll query it again. What frequency are we at? Uh, 088, I think that was. Just let you hear it again. So that's 7.088. So you can see I can change to the upper or the lower part of the band there by just throwing this switch. So now we'll go hunting for some signals on receive and see what the band is like today. And now we'll take a listen to see what the bands are like. I'm on the CW end of the band, so we'll switch it on and we'll hear the annunciator for the frequency as well. And I'll leave it at the lower speed, and then we'll check the frequency. Okay, let's see what part of the band we're on there now. I'll press it. .004. So I'm down the end of the band. I'll just go to the very end and see where it starts. This will probably be 6 point something. So it's 997, so that's 6.997. Go up the furthest end of the band there and I'll click in the higher range. Okay, so we're at the maximum frequency there. Uh, 096, so that's 7.096 there is the highest part of the band. Okay, we'll go down to the CW end. As I said, it's optimized for CW. Turn up the volume a bit. I have the narrow filter on, so I'll switch that off. Just got the tail end of that one there. So there's a Delta Lima calling there. If he calls again, I'll put on the narrow filter so that we can see the difference between the wide and narrow. Someone's come back to him there. Very weak. Try and get him. I just missed that one as well. squeeze the narrow filter in now. So it cuts in. Switch out that filter. IZ6. G station. Cheerio. So there you go, and I think you'll agree that the filter, the audio filtering, is quite effective. I go up there and see if I have any SSB signals. Probably won't be able to resolve them. So even on the wide filter position, can't resolve SSB satisfactorily. But considering that it was built as part of a transceiver, or separate transmitter and receiver, it's not bad. We'll go back to the CW again. So there's a Delta Lima in QSO with Andy there. I think it was a United Sierra station, but I'm not sure there. So I hope that's given a good cross-sectional view of the receiver and what can be achieved there at fairly reasonable cost and fairly simple circuitry. So bus 73 from Echo India 5 Echo Mike, now going QRT. This is a simplified block diagram of the receiver. Now it doesn't include all the different circuits and processes, but it gives a rough idea of what's actually happening and how the signal is received, amplified, processed and demodulated. And for the purpose of this, we're going to assume we're tuning into a signal which is on 7.020 megahertz. So it's a CW signal which hits the antenna and comes down the coax and into a 7 megs filter. Now remember, the antenna is receiving frequencies all over the place, all frequencies. So what we do is we filter it here and we just select out the 7 megs band, and we apply that signal to an RF amplifier which boosts the signal. And you can see there we've an RF gain. We can control the amount of amplification. Then the 7 megs goes into the mixer, and the 7.020 goes into the mixer. But we also have the VFO, and in our particular case the VFO is running at 2.690 megahertz. We have the varicap tuning there, so we adjust it till we get to 2.690 and we get a nice clear crisp CW tone in the receiver. So the 7.020, from it we subtract the 2.690 of the VFO. in the mixer. That's what the mixer actually does. It subtracts the two frequencies, and out of that we get 4.33 megahertz. That's our IF. It's slightly above the 4.33 because we've an audio component as well. So if you said 4.33 plus 600 hertz audio, we'll add on 600 hertz for audio. So that's our IF out. And the VFO also goes into the frequency counter, the frequency mite, and that's offset with the little shorting pins, and the audio from that goes into the audio amplifier at the end of the chain, and we hear the frequency on the speaker. But anyway, back to our IF amplifier. The IF is amplified and it goes through a crystal filter which just narrows it down. So we still have all the processing is done at this stage at 4.33 megahertz, regardless of what frequency we're listening to on the receiver. So what we do then is we put the 4.33 plus, we'll say, the 600 hertz, which is the audio component. We put that into the demodulator, which is also a mixer, and there's a crystal oscillator oscillating at 4.33 as well. So the 4.33 and the 4.33 plus 600 hertz goes into the demodulator, and out of that we get 600 hertz, which is a nice crisp CW tone. That's the one I prefer, around 600 hertz. So we feed that then into an audio filter, and you can see there we've wide and narrow. We can select the whether we want the wide or narrow filter active. And the audio then of the filter goes into our audio amplifier. As I said, also you can see going into the audio amplifier is the output from the frequency counter. There's our gain control. You can see our gain control down there below the audio amplifier, so that's our volume control, whatever you like to call it. And the output of the audio amp then goes to our speaker, and that's how we hear our lovely crisp clear CW signal. So that's a basic simplified block diagram of the Superhet. Single conversion, as I said, we're converting the received signal to 4.33, slightly above 4.33 because we have audio as well, but I haven't shown that there. But there you go, there's the full diagram there in its simplified form. So there you go. Hope you enjoyed the little presentation, and hope to hear you on the band soon. Best 7-3 from Echo India 5 Echo Mike.